Hello everyone, welcome to the first video of Calculus 1. In this video we're going to talk about the prerequisites of calculus and the areas of mathematics in which we will need in order to study calculus. Now the study of calculus is concerned with change and motion. It will deal with the idea of limits, which are having quantities approach other quantities. Now it's going to be important to have a strong foundation in the areas of math that precedes calculus, which include algebra, analytic geometry, functions, and trigonometry. So the main focus of this video is to go over these areas in order for us to be successful in calculus. So we will go through a few examples for each of the different topics, although I won't be covering every single topic that I've listed. And I encourage you to work through the problems on your own before looking at the solution. So you can pause the video, see if you can solve the problem, and then check your solutions. Now keep in mind that there may be more than one way to arrive at the solution. So as long as you don't break any rules and you can arrive at the same solution, then that's perfectly fine. So the first area of math that we'll look at is algebra. So here I've listed the order of operations. So here we want to know what the convention is for performing certain operations. And a mnemonic that is commonly used is BEDMAS. So we perform brackets first, and then exponents, then either division or multiplication, and then either addition or subtraction. We'll also want to know how to simplify and expand expressions. This may involve using the law of exponents, and we'll be focused on simplifying fractions. We want to be able to factor certain expressions, in particular polynomials. So we want to recognize when we have a difference of squares, and a certain method for factoring that I personally like to use is decomposition. Now there are other methods that can work as well, and you can use whichever method that you're most comfortable with when it comes to factoring. We can also want to rationalize certain expressions that involves square roots. And so here we can use what is called a conjugate to rationalize either the numerator or denominator. Next, we want to be able to solve equations, which can be linear, quadratic, or a trigonometric equation. And lastly, we'll want to be able to solve certain inequalities. So the first thing we'll go through is the law of exponents. This gives us a way to simplify certain expressions. So if we have two positive numbers, a and b, and x and y are any real numbers, then the law of exponents says that if I have a to the power of x times a to the power of y, then I can add the two exponents since they have the same base. If I am dividing two exponents, so I have a to the power of x divided by a to the power of y, so they have the same base, then I will subtract the exponents, so this will simplify to a to the power of x minus y. Next we have a to the power of x, which is raised to the power of y. So here we have power raised to another power. Then the rule says to multiply the two powers. So this will simplify to a to the power of x times y. And lastly, we have a times b, which is all raised to the power of x. Then this can be written as a to the power of x times b to the power of x. All right, so let's go through some examples of using the law of exponents. So here we have 16 to the power of negative 3 over 4. So let's evaluate the expression without using a calculator. Okay, so let's first deal with the negative exponent. So recall that if we want to change the exponent into a positive exponent, then we can take the reciprocal of the base. So 16 to the negative 3 over 4 is equal to 1 over 16 raised to the power of positive 3 over 4. And then we can apply the power of 3 over 4 to both terms in the numerator and then the denominator. So we have 1 to the power of 3 over 4 divided by 16 to the power of 3 over 4. Now what's 1 to the power of 3 over 4? Well, 1 to the power of anything is just equal to 1. So we have 1 over 16 to the power of 3 over 4. And now recall that when we're dealing with fractional exponents, then the value in the denominator becomes the nth root. So here we have a denominator of 4 in the exponent. So this will be equal to the 4th root of 16, and then this is all raised to the power of 3. Okay, so we change the fractional exponent of 3 over 4 into the 4th root of 16 raised to the power of 3. And now what's the 4th root of 16? Well, what number multiplied by itself 4 times gives you 16? Well, that's equal to 2. Okay, so the 4th root of 16 is equal to 2 because 2 times 2 times 2 times 2 gives you 16. And then we cube the 2, which gives us 1 over 8. Now in the next example, this one is a bit trickier since there's many more terms to deal with. So let's try to break it down step by step. All right, so what we have is x squared times y to the power of negative 1 over 2 divided by 3 times x to the power of 3 over 2 times y cubed, and this is all raised to the power of negative 2. Okay, so there's many different ways to simplify this expression. So let's first start by dealing with the negative 2 on the outside of the brackets. So again, if we want to change this to a positive exponent, we can take the reciprocal of what is inside the brackets. So this will be equal to the reciprocal of the fraction. So we have 3x to the 3 over 2 times y cubed divided by x squared times y to the negative 1/2, all raised to the power of positive 2. So we change the exponent to a positive 2 by taking the reciprocal of what is inside of the brackets. And now let's use the law of exponents. So if we have a power on the outside brackets, we can distribute the power through every term inside. Okay, so we're using the 4th rule here. We're going to apply the power of 2 to every term inside the brackets. So here we have 3 to the power of 2, and then we have x to the power of 3 over 2, and that is raised to the power of 2, times y cubed raised to the power of 2, divided by x squared to the power of 2 times y to the negative 1/2 raised to the power of 2. And so now let's simplify each of the terms. So 3 squared is equal to 9. And then we have x to the power of 3 over 2 raised to the power of 2. So here we're going to use the third law of exponent since we have a power raised to another power. So we'll multiply the two exponents together. So here we have x to the power of 3 over 2 times 2. So 3 over 2 times 2 will be equal to 3. So the 2's can cancel. Next we have y cubed times raised to the power of 2. So we're going to multiply the powers as before. So 3 times 2 gives us 6. And then we divide this by x squared to the power of 2. That's x to the 4. And then y to the negative 1/2 times 2. Well, negative 1/2 times 2 is equal to negative 1. So again, the 2's can cancel, leaving us with a negative 1. So now let's simplify this fraction. So here we have 9. We have x cubed in the numerator and x to the 4th in the denominator. So the x cubed can cancel with x to the 4, which will leave us with 1 power of x in the denominator. And now the y to the negative 1, again, we're dealing with the negative exponent. So if I take the reciprocal of y, we can move this to the numerator. So here we have y to the power of 6 times y to the power of 1. And that's all divided by x. Okay, so now we have y to the power of 6 times y to the power of 1. So now we'll use the first law of exponents, where we can add the exponents together. So that gives us 9 times y to the power of 7 divided by x. So in the next example, we want to expand and simplify x plus 2 squared. So here we want to use what squaring means. So here we have x plus 2 squared, and this means x plus 2 times x plus 2. And now we want to use the distributive property to expand the terms. So many of you may know this as FOIL. So we want to take the first term multiplied by the first term. That gives us an x squared. And then the outer terms, so x times 2 gives us a 2x. Then we have the inner terms, so we have another 2 times x. And then we multiply the last terms. So 2 times 2 gives us 4. So simplifying, we have x squared plus 4x plus 4. And a common mistake that we want to avoid is distributing the power of 2 through the brackets. Okay, so this is not the same as x squared plus 2 squared, which is x squared plus 4. Okay, so it's very tempting to do this, but we are missing the middle terms of the expansion. Okay, so we want to avoid this mistake. So next we want to look at factoring. So here we have 2x squared plus 5x minus 12. And we want to see if we can factor this expression. So the first thing we'll do is look at the first coefficient, which is 2, and the last coefficient, which is negative 12. And we want to multiply these two values together. So 2 times negative 12 gives us negative 24. And then we'll also want to look at the middle coefficient, which is positive 5. And now what we want to do is look at finding two numbers which multiply to negative 24, and the same two numbers will add to positive 5. So which two numbers will multiply to negative 24 and add to positive 5? Well, that would be positive 8 and negative 3. And now we'll use these two numbers to decompose the middle term. So we can write positive 5 as positive 8x minus 3x. So we decomposed positive 5 into positive 8x minus 3x. So what we have is 2x squared plus 8x minus 3x minus 12. Okay, so these two expressions are the same. And now what we want to do is look at the first two terms and the last two terms. And we want to take out a common factor out of both terms. So the common factor between 2x squared and 8x is a 2x. And if I factor a 2x out of the first two terms, I'm left with an x plus 4. And then when we look at the last two terms, we'll take out a negative 3. So we have negative 3. And if we take out negative 3 from negative 3x, I'm left with a positive x. And taking out negative 3 from negative 12 gives us a positive 4. So again, we want to look at the first term and the last term. And what we see is a common factor of x plus 4 from both of the two terms. So we can factor out an x plus 4 from both of these terms. So if we take out the x plus 4 from the first term, I am left with a 2x. And if we take out x plus 4 from the last term, I am left with a negative 3. And so this gives us our factorization, which is x plus 4 times 2x minus 3. Next, we'll look at simplifying rational expressions. So here we have 1 over x minus 1 over 3, and that's all divided by x minus 3. So here we're dealing with multiple fractions. So let's first deal with the numerator. So 1 over x minus 1 over 3. We want to combine these two fractions, and we want to look at finding a common denominator. So a common denominator between 1 over x and 1 over 3 is going to be a 3x. So for the first fraction, we have 1 over x. It's missing a 3. So we're going to multiply the first fraction by 3 over 3. And the second fraction is missing an x. So we're going to multiply the second fraction by x over x. And this is all divided by x minus 3. So we have 3 divided by 3x minus x divided by 3x all over x minus 3. And now that they have the same denominator, we can subtract the two fractions. So what we have is 3 minus x divided by 3x, and that's all over x minus 3. So now we're dealing with multiple fractions. Let's simplify it so that we're only working with one fraction. So the x minus 3 can be considered a fraction. It's a fraction over 1. And when we have a fraction divided by another fraction, we can simplify this by multiplying by the reciprocal of the denominator. So we have 3 minus x divided by 3x. We can multiply this by the reciprocal of x minus 3 over 1, which is 1 over x minus 3. So now let's simplify our fractions. When we multiply the two fractions, we multiply the numerators across, and then we multiply the denominators across. So 3 minus x times 1 gives us 3 minus x, and 3x times x minus 3 is 3x times x minus 3. So now we can look at the numerator and the denominator. We have a 3 minus x and an x minus 3. So they are almost the same, except they differ by a negative sign. So what we could do is factor out a negative 1 from the numerator. So if I take out negative 1 from positive 3, I am left with a negative 3. And if I take out a negative 1 from negative x, I'm left with a positive x. And this is all divided by the 3x times x minus 3. And so now if we look at the numerator and the denominator, we have a negative 3 plus x, and in the denominator we have an x minus 3. So they are the same terms, but they are in a different order. Since they are the same, we can cancel these, assuming that x cannot be equal to positive 3. Okay, so this will be simplified to negative 1 over 3x as long as x does not equal positive 3. Now there are a few examples of common mistakes that we want to avoid. So let's have a look at some of the common errors that many students can make. What we have is x plus 3 divided by x plus 2. And it's very tempting to cancel the x's in both the numerator and denominator. Sorry. And saying that this is equal to 3 over 2. However, this has to hold for any value of x. So if we choose, say, 1 for x, then what we have is 1 plus 3 over 1 plus 2. And this will give us 4 over 3, but that is not equal to 3 over 2. Okay, so we can't simplify by canceling the power of x's when we're dealing with addition in the numerator and denominator. So another common error is where we have 2x plus 3 divided by 2x plus 2. And we have a common coefficient of 2 on the x So we might be tempted to cancel these, simplifying this to x plus 3 over an x plus 2. Now again, if we choose any value of x, so let's say 1, so we have 2 times 1 plus 3 over 2 times 1 plus 2. This will give us 5 over 4, whereas on the right-hand side, if we choose 1 for x, what we have is a 1 plus 3 over a 1 plus 2, which is 4 over 3. And now these values are not equal. And a third common error when simplifying fractions is when we have 4x plus 3 divided by 4x. And so we may be tempted to cancel the 4x's, leaving us with a positive 3. And once again, we can sort of test whether this is true by choosing any value for x. So we have 4 times 1 plus 3 divided by 4 times 1. This will give us 7 over 4, which is not equal to 3. Okay, so the next example, we'll look at rationalizing the expression. So here we have the square root of 4 plus h minus 2 divided by h. And we want to rationalize the expression. In particular, we want to rationalize the numerator. So what we want to do is get rid of any square roots in the numerator. And so to rationalize the expression, we want to look at using the conjugate. So the conjugate of the square root of 4 plus h minus 2 is going to be the same values. So we have the square root of 4 plus h, and we have the 2, but we change the sign that is in between the two terms. So we go from a negative to a positive. So the square root of 4 plus h plus 2 is the conjugate of the square root of 4 plus h minus 2. So now to rationalize the expression, we're going to multiply the top and bottom of the fraction by the conjugate. So what we have is the square root of 4 plus h plus 2 divided by the square root of 4 plus h plus 2. So now let's expand the numerator. So we are foiling. So we have the square root of 4 plus h times the square root of 4 plus h. The square roots will cancel, leaving us with a 4 plus h. And then we have the square root of 4 plus h times a positive 2. That gives us plus 2 times the root of 4 plus h. Then the middle two terms, we have negative 2 times the square root of 4 plus h. And the last two terms, we have negative 4. That's all over h times the square root of 4 plus h plus 2. So now let's simplify the numerator. So if we look in the numerator, we have a positive 4 and the negative 4. So the 4's can cancel. Next we have a positive 2 4 plus h and a negative square root of 4 plus h. So the square root terms will cancel. And now all that we're left with in the numerator is an h. So we have an h divided by h times the square root of 4 plus h plus 2. And now we can simplify this further. We have a power of h in the numerator and a power of h in the denominator. So these can cancel to 1, assuming that h cannot be equal to 0. So what we have is 1 over the square root of 4 plus h plus 2, where h is not equal to 0. So now let's have a look at the next example. So here we have the equation 4 pi r minus 2000 r to the negative 2 equal to 0. So we want to try and solve the equation for r. And there's a few slightly different ways that we can approach the problem. So here, let's have a look at the 2000 r to the negative 2 term. So let's deal with the negative exponent. So recall that we can take the reciprocal of the base and change it to a positive exponent. So here we have 4 pi r minus 2000 over r squared equal to 0. And now let's make a common denominator between the two fractions. So what is the lowest common denominator? It is r squared. So we want to multiply the first term by r squared over r squared. Then we have minus 2000 over r squared equal to 0. Now that we have the same denominator, we can combine the two fractions, and we can also simplify the powers of r in the first fraction. So here we have 4 pi r cubed minus 2000 all over r squared equal to 0. And then we can multiply both sides of the equation by an r squared. So multiplying the left-hand side by r squared, we can cancel the r squared. And on the right-hand side, we have 0 times r squared. And 0 times anything is equal to 0. So we have 4 pi r cubed minus 2000 is equal to 0. So now let's isolate and solve for r. So here we have 4 pi r cubed is equal to 2000. We will divide by 4 pi, so we have r cubed is equal to 2000 over 4 pi, and this will be equal to 500 over pi. And to get rid of the power of 3, we will take the cubed root of both sides. So the cubed root of r cubed is the cubed root of 500 over pi. So r is equal to the cubed root of 500 over pi. All right, and in the next example, we want to solve the inequality. So x squared plus or minus 4x plus 3 is greater than or equal to 0. All right, so we want to see what values of x will make this inequality true. And what we have in the left-hand side is a quadratic. So we want to try and see if we can factor the left-hand side of the equation. So is x squared minus 4x plus 3 factorable? And the answer is yes. And it will factor to x minus 1 times x minus 3. Okay, so numbers that multiply to positive 3 and add to negative 4 are negative 1 and negative 3. So now we want to see when this quadratic is equal to 0. So x minus 1 times x minus 3 will be equal to 0 when x is either 1 or positive 3. So now we want to use these values to help us determine what values of x will make the quadratic positive. So here we're going to use a number line to help us find these intervals. So we're going to put the values where the quadratic is equal to 0 on the number line. So we're going to use the number line to help us determine the values of x which make the inequality true. So because we want the inequality to be greater than or equal to 0, we're going to shade in where the values are equal to 0, which are at 1 and 3. And now what we want to do is test within each of these intervals to see where the quadratic is positive. So what we want to do is choose a number between negative infinity and positive 1. For example, we can choose 0. And we're going to substitute this value into the quadratic. So here we have 0 minus 1 times 0 minus 3. Okay, that's our factored form. And this will be equal to negative 1 times negative 3, which is positive 3. Okay, and the important thing here is that the value is positive. So the inequality will be positive between the interval from negative infinity to negative 1. So we're going to shade in this region. So now we're going to test some number between the interval of 1 and 3. For example, we can choose 2. We'll substitute that into the factored form of our quadratic. So we have 2 minus 1 times 2 minus 3, which will give us positive 1 times negative 1, which is negative 2. So what this tells us is that the quadratic is going to be negative between 1 and 3. And lastly, we want to pick a value that is larger than 3. For example, we can choose 4 and then substitute it into the quadratic. So here we have 4 minus 1 times 4 minus 3, which gives us positive 3 times positive 1, which will be positive 3. So this tells us that our quadratic will be positive from the interval from 3 to infinity. So we're going to shade in this region. And so the solution are any values of x that is from the interval from negative infinity to positive 1, union positive 3 to infinity. And recall that we use square brackets when we want to include the values, and we use round brackets to exclude the values. So this concludes our examples for algebra. Next, we'll move on to analytic geometry. So some of the topics that will be useful for us are equations of lines, so finding parallel or perpendicular lines. We'll also want to look at finding the distance between 2 points on the xy plane. We'll look at the areas and volumes of certain geometric shapes. We will mainly focus on finding the equations of lines for our example, and we'll come back to the other examples as it comes up later in the course. So recall that for the equation of a line in slope-intercept form, it's given by y is equal to mx plus b, where m is the slope of the line and b is the y-intercept. Another form that I will be using more often is called the point slope form. And this is given by y minus y1, which is equal to m times x minus x1. And again, m is the slope of the line, and x1 comma y1 is any point that lies on the line. And another form of the line is called the general form and is given as ax plus bx plus c, which is equal to 0. So let's have a look at an example for finding the equation of a line. So here we have the equation. So let's find the equation for the line that passes through the point 2, negative 5 and is parallel to the line 2x minus 4y is equal to 3. So to find the equation of the line, we need to know two things. One is the slope of the line, and the other is any point which is on the line. Since we're looking for a line that passes through 2, negative 5, then that gives us our point. The only thing that we need is the slope of the line. Now, since we want to find the line that's going to be parallel to 2x minus 4y is equal to 3, then all we need to do is figure out what the slope of this line is, since parallel lines will have the same slope. All right, so what we have is 2x minus 4y is equal to 3. So if we were to rearrange the equation of the line so that it is in slope-intercept form, then we should be able to determine what the slope of the line is. So what we want to do is solve for y in the equation. So here we have 2x minus 4y is equal to 3. So now let's move the negative 4y to the right-hand side. So we're going to add the 4y. This gives us 2x is equal to 3 plus 4y. Then we'll subtract both sides by 3. This will give us 2x minus 3 is equal to 4y. And the last step is to divide by 4 on both sides. So this gives us, after simplifying, 1/2 x minus 3 over 4 is equal to y. So now if we look at the coefficient of x in this equation, this tells us what the slope of this line is. So we're given that the slope of the line is equal to 1/2. Now the point that we want to be passing through is 2, negative 5. And so this gives us our point, which is on the line. So now that we have the slope and any point which lies on the line, we can now write the equation of the line, which passes through 2, negative 5 and is parallel to 2x minus 4y equals to 3 by using the point slope form. Okay, recall that the point slope form is y minus y1, which is equal to m times x minus x1. So now we can substitute our values in. We have y1, which is negative 5. The slope of the line is 1/2, and x1 is positive 2. So we have y plus 5 is equal to 1/2 times x minus 2. And so this gives us the equation of the line.